This next video is broken down into 3 sections, from creating templates for Siemens NX feature-based machining capabilities, and then onto custom feature development. Our team has proven out similar workflows on existing supplier parts to demonstrate time and cost savings with the implementation and usage of product manufacturing information. Let's get started.
Hi, I'm Nasir Mannan, Principal Engineer here at the Connecticut Center for Advanced Technology. Today, we're going to be walking you through how to set up Siemens NX CAM to be able to take in model-based definition and automatically generate a CNC program. There's a few steps that we have to take in order to configure the software to be able to do that. We're going to walk you through first setting up a CAM template, and then we're going to go through and show you how to use feature-based machining, and then we're going to go into teaching custom features that are those features that the feature-based machining does not recognize out of the box. So here on my screen, I have opened a file with multiple different features on it. And we can also see that we have product and manufacturing information defined on some of those features that are visible here on the screen. So the first thing that we want to do is we want to make sure that we're in the manufacturing workspace. At the moment, we're in the modeling. So at the top, you can see it gives us information about the workspace that we're in. We can do this one of 2 ways. We can either go over to application and we can click on manufacturing from here, or we can go over to file and select manufacturing from here. The next dialog that's going to come up is going to ask us what environment, machining environment we want to be in. And in our particular case, we're going to go with CAM General and Mill Planer. So now that we're in the manufacturing workspace, the first thing that I like to do, and you'll notice that you'll be on a Operation Navigator tab. And on this particular tab, you have 4 sub-tabs. So we're in Program Order View. The next one over is Machine Tool View. So we want to click on that. And I like to specify a few tools for our roughing and rest machining operations. So if you right-click on General Machine, go to Insert, Tool. We can go ahead and retrieve tools from library. And in this case, it's going to be milling and mill non-indexable. Click OK. And the first tool that I want to bring on here is an inch flat end mill. So I'm going to type in 1 inch for my search parameters. Click Enter. And I have 2 options here. I'm going to choose the end mill that's longer, that does not have a corner radius. Click OK. And on the left here, you see that under generic machine, I now have a tool specified. Now I'm going to go in and choose another tool. This time we're going to do a 1/2 inch end mill. Enter. And I want to choose one that does not have a corner radius. Just want a flat end mill. We're going to go with the 1.5 inch. Click OK. And then I'm going to choose one last tool. This is going to be a 1/4 inch flat end mill. And one last tool we want to choose is a tool with a either a bull nose or a ball end mill so that we can rough out the corner fillets. So we're going to go ahead and retrieve a tool from library. And I'm going to leave this blank, and I'm just going to choose to view all the tools available. And in this particular case, I'm going to look for a corner radius that is similar to the radius of my fillets. I'm going to go with a 1/2 inch end mill with an 1/8 inch quarter radius. And at this point, I've got sufficient tools in there. I'm going to click on Cancel. And I like to view the description of my tool, so I'm going to right-click on my header here and go to Column Configurator, Configure Columns. And I'm going to choose to put my description of the tool first. Click Apply, Cancel. Now I see what my tools are. So next we want to set up our workpiece and our bounding box. So we're going to go over to our geometry view and we're going to expand MCS main and expand workpiece. So here we're going to right click on workpiece, select edit, and we're going to specify our part. Click on our part that's in the graphics area there, click OK, and now specifying blank. We just want to do a square stock. So we're going to go ahead and select bounding block, and we're going to want about 100 thousandths overall, about 50 thousandths additional material on each side. So I'm going to go ahead and type in 100 thousandths additional material, and then on my Z I want this to have additional material on the top of my part. With the bottom, we're going to assume that we would have done a facing operation at the bottom to get that flat. So we're going to push this up 100 thousandths, and this way we've got material on the top and on all sides of the part of the piece. Click OK, and we want to make sure that the description, I like to call this the workpiece, and the material here we can select as aluminum, and then click OK. Next we want to set up our machine coordinate system, the local machine coordinate system. Right click on MCS local, edit, and we want to specify this on the blank. And in this particular case, we want it at the front left top corner. So we're going to go ahead and hover our mouse over the different corners in our blank view. And I can see in the graphics area that it's highlighted the corner that I want the coordinate system to be at. So I'm going to click on that. And in our case, Z pointing upwards is correct, but I want Y pointing back and X pointing right. So I'm going to go ahead and grab the manipulator and rotate it 90 degrees. And now we have our coordinate system set correctly. So you can click on OK. And at this point, we have now specified to NX what our workpiece is and what our stock material is. And we've specified our MCS local. So now that we have our workpiece defined and our coordinate system defined, we want to be able to set up a few roughing operations that we want to save in our template file. So what we're going to do is go over into our program order view, and you can see here that I have one program. I want to right click on my program, insert operation, and the first operation that I want to set here, we want to go to mill contour as our type. This will give us access to our 3D adaptive roughing. So we're going to go ahead and click on that. We want to make sure that program is specified as program. We want our tool to be our 1-inch flat end mill that we specified and added to our tool library. For our geometry, we want this to be the workpiece. Make sure by default Siemens selects the machine coordinate system local. We want to change that to workpiece. And we're going to do that throughout creating every one of our tool paths. And then for our method, we want this to be a mill rough. So we're going to go ahead and leave the name by the default. Click OK. And what we want to do in this window is specify our parameters for the roughing operation. So for our step over, I like this to be constant, and I like it to be a specified amount. So the step over here, we're going to specify it to be 100 thousandths. And then depth of cut, we want this to be also constant at 100 thousandths. Everything else can remain default. If we go over to the geometry tab, we want to make sure that we have 20 thousandths left over on the blank, because we're going to go and do a rest machining operation. Right now we're just going to go through and remove a lot of the material here that needs to be removed so that we can get to the features, but we want to leave some material on there for subsequent operations. So we're going to go ahead and click on 20 thousandths, click on OK. So now that we have our workpiece defined and our local machine coordinate system defined, we're going to go ahead and add some roughing operations, and we're going to save that in the template file so that we can then reapply that the next time we import a different part. The first thing that we want to do is go over to our Program Order View tab, right-click on Program, Insert Operation, and in this case we want to make sure that our type is set to mill contour, and we want to select the 3D Adaptive Roughing. Down at the bottom here for location, we want to make sure that Program is selected. We want our tool to be a 1-inch flat end mill. Geometry is workpiece. By default, NX specifies the local machine coordinate system. You want to change this to workpiece, and this is going to be a common theme for each of the machining operations that we add going forward. And then we want our method to be specified as mill rough. I'm going to leave the name as default, click OK. This is going to open up our dialog that allows us to set parameters for this adaptive milling operation. Our tool should already be set from the previous dialog, and what I like to do for the step over is have a constant and specify it in inches, so we're going to go with 100,000 step over. In fact, we're going to go with 150 thousandths. And then for our depth of cut, we want this also to be constant, and we're going to specify this to be 150 thousandths. We're going to leave the rest of the parameters as default and go over to the geometry. For our part stock, we want to leave 40 thousandths of material, so by default that was already set, and we're going to leave everything else as default. That's all we're going to change is this dialog. Down at the bottom we have the option to generate the tool path. We're going to go ahead and click on that, and this is going to initiate NX to generate the roughing path that we can then view in 3D on the part. The next step is to verify the tool path. If we click on the verify button, we want to be in 3D dynamic and click the play button to see how that tool path looks. So our purpose for generating this first roughing operation is to clear as much material as we can off of the part. We're going to add another machining operation called rest milling, where we're going to use a slightly smaller diameter end mill, and we're going to remove some more of that material that we purposely left on in this particular operation. I'm going to speed it up here so we can get to the end. Make sure that we're not going to have the tool go through any of the features that need to remain on the part, and that looks good there. And I can see here, because I can't see the CAD through the material, that I have positive material left over for me to then cut away from. So I'm going to click OK and OK in the 3D adaptive roughing operation dialog to then add that to my tree. Now what I want to make sure is, if I go over to my geometry view, that my 3D adaptive roughing operation is under my local machine coordinate system. If it's not, you can click and drag it so that it finds its way underneath that tree item. Again, back over to our program order view, I'm going to add another operation. If we go and right click on program, insert operation, or alternatively, I can look up here and I have some commonly used machining operations. In my case, I have rest milling, so I'm going to click on that. And we're going to specify our 1/2-inch flat end mill as the tool to use for this. We're going to keep the cut pattern on follow part, and we're going to keep the step over as constant, and we're going to go with 100,000 step over. And for our common depth of cut, we're going to increase this to 50 thousandths. For our in-process workpiece, we're going to use 3D, and we're going to leave everything else default. Over on our geometry tab, we're going to set our geometry to be workpiece. and we don't want to leave any additional stock material. We're going to cut it down to the CAD surface. We can leave everything else as default and generate the toolpath. And we're going to verify that this toolpath. Again, make sure that you're on the 3D Dynamic tab and click on play. In this particular case, because we're using the 1/2" end mill with a corner radius, we're going to be able to, in this particular operation, take care of all of the fillets on this particular part. I'm going to speed this up just to verify that we don't have any tool crashes. And the end geometry looks good there. So the areas where it was not able to get the tool into are on this top slot feature. And to fully cut this slot on the back of the part. So we're going to click on OK, and we'll accept that toolpath. And we're going to add one more rest milling operation. This time we're going to choose to use our 1/4" flat end mill. And we're going to leave the cut pattern on follow path. We're going to set the step over to constant. In this case, we're going to set it to 50 thousandths. And we're going to leave our depth of cut to be 20 thousandths. Leave everything else as default. Back over in the geometry tab. We just want to make sure that there's 0 part side stock specified so that the tool cuts down to the CAD surface. I'm going to generate the toolpath, and this time we should have a toolpath that's only generated for the regions that the larger tool was not able to get into. Let's verify that by clicking on the verify button, and we're going to set the speed to 1/2. And verify that toolpath. In this case, we've added a 3D adaptive roughing operation to get rid of the bulk of the material with a large diameter tool. Then we chose to use a tool that had a smaller diameter to do the secondary rest milling operation. And that particular tool had a corner radius. We chose that tool because the part has some fillets in it, and we could take care of cutting those fillets with that particular tool. It would get rid of more of that leftover material from the previous 3D adaptive roughing operation. And then now we've gone through and chosen to add a third operation, or a second rough milling operation with a smaller diameter tool, in this case the 1/4" flat end mill. And that tool is able to get into the smaller areas that the 2 other larger tools weren't able to get into. In this case, now that the tool path has been verified, we can see that the majority of the operations have resulted in producing a good result. We don't see the tool going through any of the features. We don't see any gouges, and so this tool path in terms of the verification looks good. So we can click OK, and we can click OK so that we accept the tool path and get out of the rest milling dialog. Now that we have our roughing operation set, we can save those operations in our template file. What we want to do is go ahead and shift select all of our operations, right click, go to object, and then we can go to template setting, and we want to make sure that object can be used as template is checked on, as well as create if parent is created, checked on. Next, we want to go over to our tools. We want to make sure that these particular tools are used for those operations. So if we shift select everything, right click, object, teach setting, again we want to make sure that both options for the template setting are selected on. And then we just want to double check to make sure this should already be set, but I'm going to go ahead and right click on the operations again, go to object, template setting, just to verify that both options for the template setting are saved. In this particular case, that's all we need to do. We can go to File, Save As. We're going to add template at the end of this file name and click OK. Now that we have our template file created, what we can do is load up our template file and then import our geometry. And we can apply that template file. So all the steps that we just went through to set up that template file, the 3D adaptive roughing followed by the 2 rest machining operations, choosing the correct tool, setting the parameters for each of those operations, all of that time can be saved by just applying the template file. Again, this is a way for you to just simply make the process of coming up with a CNC program to machine a part that much easier. Now that we've cleared our workspace, we can go ahead and open the file. And we can go into our manufacturing workspace. And in this case, we're presented with the machining environment dialog. We want to make sure that we're at CAM General, but instead of selecting one of the CAM setup templates, we can go ahead and browse for a setup part. And we're going to go and load the template file that we just saved. Click OK. And you can see now that we have that added as our CAM setup template. We can go ahead and click OK. And in this particular case, since we loaded our template onto this file, we can see that if we expand MCS main, we already have our machining operation set. If we go over to our machine tool view, you can see that our tooling also came in. Expand our program, again just verifying. We have our 3D adaptive roughing, rest milling, and our secondary rest milling operation already there. These will contain all of the parameters that we specified when we save the template file. So that'll save us all that time. All we have to do now is if we go over to our geometry view, we just want to make sure that our workpiece is set correctly. So we go to right click on workpiece, click on edit, specify part. And in our particular case, it's already pre-selected. Since we only had one body in the template file, it's going to select the single body that's there. So click OK. And we want to specify our blank, the specify blank button. You can see that we already, by default, it already added 50 thousandths to each side and 100 thousandths to the top. So we don't have to do anything there. Just click on OK. We'll leave the description as workpiece, and it's already selected the material as aluminum, so we can click on OK there. Now at this point, all we have to do is if we go over to our program view, select program, and then select generate toolpath. With this single push of a button, we're going to generate 3 machining operations, the 3D adaptive milling and the 2 rest milling operations that we specified in the template file. We do not have to go in and specify any other parameters. It's going to use the parameters that were saved in that template file. Again, saving us all that much more time. We can accept the paths after generation up at the top in the Home tab. If we go to the right, so long as we have program highlighted in the tree, we can select Verify Toolpath. And I want to make sure I'm on 3D Dynamic tab. My speed is set to half, and I'm going to go ahead and verify that toolpath. So first, it's going to go through the 3D adaptive milling. That's going to get rid of the majority or the bulk of the material with the 1-inch flat end mill. And then we should see it continue with using the 1/2-inch corner radius end mill to get rid of the remaining material. And then for those areas that particular tool couldn't get into, it's going to switch over and to the 1/4-inch end mill and machine away the material that's left in the slot and in the pockets. You can see the benefit of having used a template file. All I had to do was open up my part, apply the template, verify my workpiece and my coordinate system were set correctly, and then with a single push of a button, I had my entire roughing operation automatically generated in Siemens NX CAM. We can then verify that path, and through the verification, we can make sure that we don't have any gouges, that the tool doesn't go through any of the features. And in this particular case, we see that it generated a usable path. Now all we have to do is use the feature-based machining to machine the rest of the features that weren't machined during the roughing operation. We can click out of the tool path visualization by clicking OK. And now we're going to go into using the feature-based machining of Siemens NX CAM. If we go over to our machining feature navigator, right-click in an empty area of the tree. We want to find features. And we're going to be presented with a dialog that's going to give us some options on what features we want NX to find. In our case, we're going to choose to have it look for parametric features. That is bosses, corner notches, grooves, holes, pockets, so on and so forth. I've turned off turning and wire EDM because that is not the process that we're going to be using to produce this part. All of the other features we can look for. In fact, we can turn off surfaces as well. We want to make sure that our search method is set to workpiece. And we can specify a vector. So the vector is giving the direction of the tool that the tool is going to come down at. So I'm going to choose to use this corner edge here to specify the vector. Our tool is going to come down in the Z direction, and so you can see the arrow pointing upwards is the correct orientation that we want. And now we can select Find Features button. NX will now go through and find all the prismatic features that it can identify on the part. Highlighted in red here on my workpiece, I can see all of the features that it's recognized. If we turn on surfaces, we can find features again to see if it finds the pockets. In that particular case, we're now finding the top flats of the two irregular bosses at the back of the part, and then the surface at the bottom of the pocket. We can click on OK. And if we expand our feature navigator, tree view, you can see all of the prismatic features that NX has found. Now we can go over and highlight all of the features that NX found. Right click, and we can create our feature process. This will bring up our create feature process dialog, and we can choose what processes we'd like NX CAM to automatically generate. I'm going to choose to select and leave all of the default processes on. Since I didn't have turning and wire EDM selected as features to be recognized in the previous dialog, those should automatically be unselected. Make sure that the geometry is set to workpiece, and we're going to click on OK. From here, we can go over to our operation navigator, and you can see the additional feature processes that were created. If we select, we can take a look at the geometries that those are associated with. We have spot and chamfer for these top patterned hole feature. We have a spot drilling operation, spot and chamfer there for that top chamfered feature that's on that larger hole. And we can choose to go through and verify what geometries are associated with each of these machining operations. At this point, I'd like it to just generate the toolpath, and we'll go straight into verification. So if I click on Program, we're going to generate toolpath. Once it's done, we're going to go into our Verify toolpath to see the result. So the generation of the toolpath is complete. I can choose to accept the paths. I'm not going to take a look at any other warnings since we're going to go directly into the Verify toolpath dialog. And I want to make sure I'm in 3D dynamic again. So now we can go ahead and hit the play button to verify the toolpath. You can see that the machining program that was created doesn't need to be modified in any way. There's no gouges on the part. The tool never goes through any of the features. This is a fully usable CNC program that we can now post out for production. If we click on OK out of the toolpath visualization, we can actually come into the machine tool view and see that NX automatically selected the appropriate tools to use to produce the features that it recognized in the feature-based machining function. So that saved us a ton of time. We didn't have to go through and measure each feature and choose the appropriate spot drill or the appropriate drill or the appropriate end mill to be able to produce that feature. This is yet another time savings that the feature-based machining function within NX affords us. We do notice, after having run the verify toolpath, that there are two areas on our part that were not machined. These are custom spherical indents that were put in on this part to be able to show how we can actually teach Siemens NX CAM to recognize custom features that aren't necessarily part of the feature-based machining toolbox. Now we're going to teach Siemens NX the custom feature. If we go into the Machining Feature Navigator tab on the left, right-click on an empty area, we're going to go to Teach Features. This will open up our Teach Feature dialog. We want to expand Machining Feature, click on Customer Feature, and we want to add new feature type. In this case, we'll call it Indent. And then under Recognition Rule, we want to select Customer Features and Add New Rule. By default, it's going to grab the name that we assigned under Customer Feature, under Feature Type. And now we can select the geometry that's associated with that feature. We're going to select the spherical indent on the part, and then we're going to click on Teach Recognition Rule. As soon as it does that, it's going to identify any other features of that type. So you can see in the 3D graphics area that the other spherical indent has been selected. We can click on OK. And now that we've taught that customer feature, we can right-click again in the empty area on the tree, find features, and then we're just going to look for the custom feature that we just taught NX to find, rather than all of the other parametric features that are that come with NX. So we're going to select Find Features, and you can see here on the part we have those two spherical indents recognized. So if we click on OK, you'll notice in our Machining Feature Navigator on our tree, we now have the two last additional indents now part of our tree. If we select both of them, we can right-click and group these features. We want to make sure that the geometry is associated with the workpiece, and we can click on Create Feature Groups. It's going to name it Feature Group or FG_indent. And if we expand our groups view here, you'll see the current groups that we have. And if we click on OK, we'll see the FG indent now added as part of our group. And if we expand that, you can see that it contains the two spherical indents now. If we go back to our Operation Navigator, you'll see a new feature group under Workpiece. If we select that, you'll see that it highlights those two spherical indents that we just taught NX to recognize. Now that we taught NX a custom feature, we're going to teach it how to machine that feature. If we go over to our Operation Navigator, we can select the new taught feature group, right-click, insert operation. Our type is going to be set to mill contour, and our operation subtype, we're going to choose to use a contour area path. We're going to let this go under the program. We're going to choose a 1/8" ball end mill. The geometry we're going to leave as our indent feature group. And then for method, we're going to leave this as mill finish. Click on OK. This will open up the area mill dialog, and we can set our parameters for the path here. For non-steep cut pattern, we're going to go with a spiral. And then for our steep cut pattern, we're going to go with level helical. We're going to choose to have a constant step over distance of 10,000. And over in our geometry tab, we're going to select our areas, our geometry to be our 2 indents. And now we can generate the toolpath and verify that this looks appropriate. So that looks good. Click on OK and OK to exit the area mill dialog. And now under the feature group indent, we have an area mill specified. In order for us to teach NX to use this same toolpath every time it recognizes the indent feature group, we can right click on the feature group, select Object, and Teach Operation Sets. This will open up the Teach Operation Sets dialog, and if we select feature group under Operation Sets, all we have to do at this point is select Teach Machining Rule. Now that we've taught NX how to machine that custom feature, let's see how it applies this in practice. Now in our Machining Feature Navigator, we're going to right click on an empty area, find Features. We want to make sure that we're only finding the custom features that we taught it, so we're not going to check on any of the parametric features. Click on Find Features, and you can see that NX has successfully found those 2 spherical indents. Click on OK. Now we can go directly to creating a feature process. So select both index, right click, create feature process. And we want to make sure that we're not going through all of the different features. We're just going to have it create the operation set for the indents. And so we have just the operation set selected. Make sure the geometry is selected to workpiece and click on OK. And now if we go over to our Operation Navigator, you can see that we have a feature group indent with the assigned area mill operation to that feature group. Now all we have to do is select workpiece and generate our toolpath. We're going to accept the paths and then just select on the area mill path, and we're going to verify that toolpath. And that looks perfect. Here we can really see the power of Siemens NX CAM. Not only are we able to create a CAM template that contains our roughing operations that remove the majority of the material that we need to remove off the part, but we can use the out-of-the-box feature-based machining to recognize parametric features. NX will automatically select tools and the appropriate operation sets to produce those features. And any features that it doesn't recognize, we have the ability to teach it custom features and further to teach it how to produce those features with operation sets. All of this is there to help you save time and ultimately help you save costs for your manufacturing operations. I'm Nasir Mannan, Principal Engineer here at the Connecticut Center for Advanced Technology. Thank you for watching.